Hi guys, welcome to Learn Electronics Repair, another PCBWay sponsored video and another with my friend Detlef. Okay, hey guys. So Detlef has a story to tell us, so where do we begin?
Yeah, but this begins at the end of the live stream.
Okay.
I don't know, 6 weeks ago, 8 weeks ago.
Yeah.
Some time has passed.
Yeah.
And I think, but at the end of the live stream, we were asking the people, so you out there,
What projects?
What projects, if you were interested in some projects. And I think one of the guys, this is my memory.
And there's always one, isn't there?
Yeah, came up with, do a CPU tester. And both of us were going for, nah, way too complicated.
Yeah.
No.
And I say there's always one, isn't there?
Yeah.
Come up with things like that.
And then we went for kebab.
We did go for a kebab.
Yeah. So here's a nice kebab place down the road here. And and after the show we were talking and this came back to us. And we thought, okay, CPU tester, nah, still too complicated. But we came up with the idea, if we have a CPU tester that simply does a thing where it simply sends NOPs, no operation.
No operations, yes.
Codes to the CPU. This would simply go through all its addresses. So
and reading the instruction, no op, and go to the next one. Yeah.
Count up from 0, nop, up to 65,000, blah,
536.
This one.
Yep.
And starts and over. So
somebody's going to correct us. 65,535 because it starts from 0.
Yep. Yeah.
See, you don't have to comment on that now.
Stop writing now.
Yeah. Okay.
So we thought, okay, this is feasible and we probably can do this.
Yeah.
And this is how the NOPPER was born.
Yeah. So basically what this does is, with a processor, it will put the first address out and read the instruction on the data bus. And this is an 8-bit processor. There's 8 data lines. So we had to look up what is the binary for a no-op for our processor.
00. Yeah.
It's 00. So
for a Z80.
For a Z80, yeah. So this is the Z80 edition. So for the Z80, all we do is effectively connect all the data lines to ground. And then whatever address it sends out, it will read 0.
Yeah.
And like that says. So basically, this is just a very complicated binary counter.
16 bits. Yeah.
16 bits, yeah.
Probably the most complicated way you can do this.
Exactly. Yeah. So, on the other side, what do we see here?
On the left side, you see A0, A1 till down to A15. So this is all the address lines you can see on the Z80. It's a 16-bit address bus. So this is where the 64K are coming from.
Yeah. And they all the LEDs we have there. Yeah. Let's get in there.
Yeah.
Woo!
Tiny ones.
Tiny LEDs.
Yeah.
Yeah.
So clearly this is a PCB you don't want to solder by hand. And we
didn't.
The nice folks at PCBWay did this for us, right?
Yep, they did. So we didn't do it. PCBWay assembled these. So if this works, this is a shared project for you guys. And you can either torture yourself by soldering these yourself, or you can just pay PCBWay to do it.
What was the price tag for one board?
I'll have a look right now. Yeah, so we have 5 of these and it came to, let's say, $35, so $7 each. That's constructed. Everything apart from the ZIF socket to put the processor in, which we decided to solder ourselves.
Yeah, we weren't sure if they would provide the right part and
Yeah, you can ignore these freight costs, because it doesn't apply to you. That's the main thing. Also, because these are sponsored videos, PCBWay do provide these products for us for free, and they put them on an expensive delivery so we can get a video made. So this was DHL.
Yeah, this was really fast.
It was really fast, but you can pay about $5 for a delivery. And again, with tax, I mean, where there's any tax depends on where you live. In actual fact, this is an error because in the Canary Islands, we don't pay any input duty or VAT. Yeah.
Nope. Take this, Donald.
Yes, take this, Donald. Yeah, but anyway, because it was free, we're not going to argue with them. Okay?
No, we don't.
It was free anyway.
Yeah. And again, when you think, okay, $7 for a PCB, this is assembled for you. So ask yourself, how much is my time worth? And building this stuff takes about what you guess? An hour?
An hour easy. Well, all them tiny little LEDs. Okay, so there you go, guys. If you want to, when you go to the shared project, you have the option to say assembled or not. So it's up to you.
Yep.
So we have a very nice PCB assembled, as you can see. Now, we will confess straight away that this is standing on the shoulders of giants because, Detlef,
yeah, of course, I had to look around. When I came up with the idea, was, did somebody else build this before? And yeah, of course, somebody else did build this before. And yeah, sadly, I don't have the link left anymore. But in fact, this is pretty much what I would have done. So down on the left bottom corner where the variable resistor is. You do the pointing today, okay?
I am.
Yeah. There's a little NA555 sitting, so a timer chip that simply generates a clock pulse.
Yeah.
And we feed this directly into the CPU somewhere on clock, I think pin 6 or something, yeah.
Yep, clock.
Yeah. Yeah. And we have a little reset circuit down there, so where the missing button is.
Okay, there.
Yeah.
Okay,
Yeah.
so we need a button also.
Yeah, we had a problem with the footprint there, and PCBWay wasn't sure about what they want to put on there, so we said leave it open. This is revision 0 because we aren't sure if this will work. So this is our first test for you guys. So,
Exactly. Did the original project have USB-C? Because I think you just had the schematic, didn't you, basically, from like an instructables or something like that?
Yeah, I saw the schematics and I thought, yep, okay, this is how I would do this. So I was very happy. They did everything in through-hole. So I wanted to have something compact that can be manufactured by PCBWay because they like more SMD stuff. If you have a through-hole, they need to solder this by hand, and this can be done by a machine.
Yeah.
And since it's 2025, we wanted to have USB-C as power input, of course. What I did, you see the second row beside the CPU where it says where all the pin names are out. So this is up to you. You can solder a pin header there, or the female pin header, so you can put DuPont cables in there, or you can leave it open just to measure on this. This is just for more easy kind of measuring, not poking around at the CPU itself.
So theoretically, you could put a little shield or board on here with an EEPROM and actually write some software.
No, you can't.
And you can't because?
The data lines are already CD, where it says DD something something. Yeah, this is pulled to 00. So
okay.
Sorry.
That is a possibility on the revision 1 that we could do so, I guess. And then you could just omit these resistors. Maybe.
You could, but I think this is more a go or no-go situation. So if you have a CPU lying around and you're not sure if this does something, if it's barely alive, this is the way to go, because this will count up to 64K, depending on how fast the NA555 puts out the pulses. And after this doesn't do a complete function check. So this is in no way a guaranteed working thing, but it's a go or no-go thing.
Okay, well, you guys have a think about it. Let us know. I mean, maybe a breakout board if we wanted to write some software, but we need changing in some way with the hardware.
Yeah.
Okay.
And yeah, then we got the boards, and we thought, perfect. Now we need to test this.
We need to test this.
Yeah. And guess what?
We don't have a Z80, but we do have a friend, and our friend Carlos, if you know from the live streams on this channel, he's very much into retro hardware.
So he lent us
a Spectrum. So this is a ZX Spectrum for those who've never seen one. This is Carlos's. This does work, I believe, now.
We think.
We think it works. So this has a modification here to replace one of the voltage regulators, and I'm pretty sure this is also a modification up here as well. I mean, I remember repairing Spectrums back in the day. This thing is a factory mod. So this transistor strapped across the processor was something that was done in production. Obviously, that's what's called a botch.
This is a botch, yeah.
Yeah. And this here is actually the Z80, although it's an NEC chip, not a Zilog chip, but it is an equivalent of a Z80. So to test our NOPPER, we're going to have to take this off the board.
How do you want to do this?
How do we want to do this? Well, we want to do it our way. So I said to Carlos, look, if we can take it off, can we use it? He says, yes, but fit me a socket. So that's the penance. So I'm now going to remove the processor from this, and I'm going to fit a socket for it to go back in. We still need to solder the transistor back across it, but it's much easier to change if they need to change. And then we can use the processor to test our NOPPER, and our NOPPER to test the processor. So let's see how we're going to unsolder this.
How would you... this is an old board, right? This is about 40 years old or something.
Yes.
Yeah. We need to rescue the CPU because we need the CPU. How would you do this if you know there's a bad chip on that. How would you go with when you
Okay. Yeah, I get what you're saying. So back in the day, I used to repair these. I'm not saying I used to take them into work with me and use the desoldering equipment where I worked, so it was better than mine. But what we would do is, if we were changing all the RAM, for example, we would just actually cut all the pins off these chips, just remove the bodies and then actually unsolder the pins directly. If I took it into work, obviously in my lunch break and not in work time, I could use the paste vacuum desoldering tools we had, which were basically something equivalent of this. These boards are fiberglass, so they're not actually paper resin, so they're a bit more durable than boards of the 70s and 80s. But we have to be careful, so I'm going to unsolder the process, and obviously we want to leave all the legs on. So let's try this and let's see if we can get this out in one piece and leave the PCB in one piece. Okay, so that took me 8 to 10 minutes, something like that. You can see, I think if we just look at a few of these pins are actually free, I believe, but we'll look from the other side. I mean, they're looking good to me, these are. So these should come out. The question is, we need to just make sure it's actually soldered properly from the other side. So let's see. Looks good. Yeah.
This looks really good, yeah.
It does, doesn't it? So let's see if we can just get this out of here now without applying much pressure. So I was saying to Det while I was doing that, when I'm kind of waggling the desoldering tool, I'm not putting any downwards pressure. Because that's another way to strip pads. Just want to make sure this is actually, yeah, you see?
Ooh.
Without any pressure on that. There. How about that?
This came out nice.
Yeah.
Wow.
So now we have a processor. We can test the processor and test the NOPPER.
Yay.
But before we can do that, of course, we need a socket. So we have a 40-pin ZIF socket here.
That we stole from Carlos.
Yeah, we appropriate. I think we exchanged in exchange for doing the other thing, but he also gave us this. So you could actually fit one of these if you're not doing many processors. It's not really a problem.
This will work with a normal socket. You don't need a ZIF socket for that.
No, exactly. I'm just looking at this socket. Actually, it looks like there's some crap in some of it.
What the heck? Yeah, you're right.
Yeah. Okay, we'll try that another
Okay, we'll maybe want to check this out before.
Yes, we want to put the processor in the socket before we stick it in the board.
Yeah, and this is a moment of truth because let's hope my layout was good.
This is so true. Look, all the pins are bent.
Ah, what happened to this poor thing?
Carlos, can you explain why these are all? Carlos, it looks like it happened to this. Yeah. I don't know what's going on there. It wasn't us, we didn't do anything to it, I'm sure.
No.
No. I told you not to jam this into them drawers to get it to fit.
Yeah, I remember.
So,
Ouch.
a little bit of adjustment. I think probably if I can actually get the pins to go through the holes in the PCB, I can probably just kind of push the thing in one direction.
I think I remember to make the holes extra large for the ZIF socket. I think I remember.
You think you remember?
Yeah, it's a revision zero, you know.
We find out, so we can do this. Yeah. Okay, so you didn't see that on video, but Detlef couldn't do it either, and I finally did it.
There,
yeah. So I think on another revision we make these holes a little bit wider. Yeah, just a little bit wider so that it fits in more easily. So there's our socket. It's in the right way round. Pin 1, pin 1. So we'll solder this into here. In the meantime, I actually tried fitting the processor into this socket. So it must have been a bit of flux in there, but it's all cleared out. So the CPU will fit in there. So we can fit this socket onto the Spectral. And then we can put the CPU back in. So let's try this. Okay guys, so one nicely soldered ZIF socket. Oh, I just see there, I don't think it's actually a bridge, but I'll just get that. I think it's a bit of paper actually from where that was just
Could be, yeah.
cleaning it up. Well,
Looks nice.
it's gone anyway, okay. So, how do we use this net?
Moment of truth, right?
Okay,
Just drop a CPU in there and connect USB. Grab a power bank.
okay. So CPU, and what does it do?
It should do a counter.
We need a reset switch.
You maybe want to switch on the power bank.
Switch on the power bank. Okay, here we go, guys.
Okay, there was something.
Oh, it's counting.
It's counting?
Yeah. It's counting slowly.
Very slowly.
Let's try adjusting the speed. So, I think we figured this was working at a very low frequency, actual fact.
Oh yeah, this looks way better. Oh, and it's counting. We maybe want to turn on the lights a bit.
We maybe do. Or we just tilt it.
No, we have to turn on the lights. Ooh, this is a Christmassy thing. Julie will love this.
Yeah, so it counts up in binary.
Yeah.
And we can see all the LEDs going up.
Like we expected to.
Correct.
So what the CPU currently is doing, it's starting to putting out some address, the address we don't care about,
Yeah.
and it reads back what its next instruction would be.
And it's no operation, go to the next address.
Yeah, so NOP will be simply do nothing.
Go to the next address.
Yeah, and so it goes to the next address, and what it does by that, it does a binary counter, a 16-bit binary counter, because 16-bit address space.
So we can see it's counting through all the addresses. So this frequency will take a little while.
Yeah, it will.
I think we could change the value of the capacitor to something smaller, or we could. I'm guessing there's a resistor in series with this, so that
Yeah.
to set a minimum resistance. So I would say we probably want a smaller capacitor, but we can see it working though.
But you know what? This CPU is doing something. This CPU is going through all the non-operations that we threw in at it.
Yeah.
And it's doing this fine. So as a go or no-go test, I'd say this CPU works.
I would say this is fine.
Yeah.
Yeah, it'll obviously take a while to get to the higher addresses because it's counting through each one. So effectively, as it goes to the next address on here, which it has unjust, and then we have to go to
Oh, yeah.
one and so on. Two, yeah. So the next will come up with 3 here, and then
A8.
4. So that's 3.
There goes A8.
Yeah, and then it'll go to just A10 plus A8.
Yeah.
Oh, no, sorry, A10, 4, and then A10, A8. So yeah, it is working. I mean, we could discuss maybe increasing the frequency a bit.
You could, but you don't need to. This is not we need to do this thing, because, well, CPU is doing.
Yeah, it's testing. So when we eventually get to them all lit up, it will go back to 0. At least I suppose at this rate we can actually see that they're flashing at different rates. You see it quite clearly here.
And to check if the CPU is doing something, you don't need more.
No. So there is our NOPPER. It works.
Okay.
We've just switched off the overhead lighting so you can see it a bit better now. Okay. So, could we use this to test other processors, Det?
Sadly not. This is a one-shot thing. For once, the knob operation for, say, a 6502 that works in a Commodore C64 is a different value than the 00. You could use a microcontroller to switch this. Say you have a little display, you say select the Z80, select the 6502.
Yeah.
But the next problem is it's on different pins.
Yeah.
And we're having something like an address bus that must be connected, and we would need drivers on all 40 pins for that, and we need to switch directions probably. So not that easy. I think it's more easy if you have something like that to just build another device, because we simply if we would do a 6502.
Yeah, 6502 version.
Yeah. If we would do that, we simply use the NOP opcode for do nothing for the data bus, and get the address bus from there. So that would be the thing.
Okay.
Yeah. If you want to demonstrate what the reset does, you simply could
short the reset.
The pins.
Yes, if we short the reset with some tweezers.
If you want to do that.
We can. So this will actually set it to counting from 0 again.
Yeah. Yeah.
Okay, let's just do it. It's a reset switch. Watch the counter, guys. There we go. So the reset switch just resets the counter back to the beginning. Yeah. Interesting. I guess you could probably put a board on here and play with things like non-maskable interrupts. I mean, you could do what you want with this, you know. I mean, guys, this is like a revision 0, but we like it, and there's a kind of a go, no-go. It won't tell you definitely the processor is good. It may have some obscure fault, but it will certainly tell you if you got one that's definitely bad. And that's got to be a bonus.
I think so. So if you're into 8-bit computing, retro computing, this is probably a project for you that you can build for pretty cheap from PCBWay.
Yeah, pretty cheap.
Yeah.
So we'll get us uploading now as a shared project. You will find it in the video description below.
Upsides are there's no software included, so you don't have to do an EEPROM, you don't have to program anything, you just build the thing. What would you say, €7 for a PCB like that?
Yeah, we worked out €7. Yeah. Assembled.
Assembled, yeah.
So guys, 3 things. First of all, do you want us to make a 6502 version? Yeah. Secondly, would you add any extra functions to this? We talked about a daughter board. What would you do with it? Yeah. And thirdly, apart from the Z80 and 6502, do you think there's any other commonly used processors and retro equipment that we should make a version of? So we'll leave you with that thought. Hope you enjoyed that. Talk to us down there, and we'll see you all soon again on Learning Electronics Repair. Ciao for now, guys.